f of g of x. So our f of x is 2x minus 1 with the domain restriction where x is greater than 0, greater than or equal to 0, but less than or equal to 3. And for g of x, which equals 3x, we have to be between 1 and 3, but that includes 1 and 3 as well. So the first thing I want to do is let's just make a chart and see what's happening in each of these functions. So for f of x, let's just plug in values real quick. So if we plug in 0 for f of x, we get 2 times 0, which is 0 minus 1, which is negative 1. If we plug in 1, we get 2 minus 1, which is 1. And if we plug in 2, we get 2 times 2, which is 4 minus 1, which is 3. If we plug in 3, we get 6 minus 1, which is 5. So let's do the same thing for our g of x. So for our g of x, we have the 0 in our graph here, but notice we're not actually allowed to plug in our 0 because of our domain restriction. We're only allowed to plug in values between 1 and 3. So here I'll just make, I'll just write not applicable. This isn't like mathematical notation, it's just a way to, actually it just looks like n divided by a. But yeah, it's just non-applicable. It just means there's no value here for this. Actually, let's just erase this. We'll just draw a big line through it so it's less confusing. So yeah, nothing. So, but we can plug in 1 through 3, so let's try that. So 3 times 1 is 3, 3 times 2 is 6, 3 times 5 is, 3 times 3 is 9. Okay, so now, keeping this chart in mind, we want to ask ourselves, what is the domain of f of g of x? Well, let's talk about real quick, what does domain mean? Domain is essentially what are the legal numbers that we can plug into this equation. So, since when you do compositions of functions, you first start plugging values into g of x, we know right off the bat, so step one should be, we know that we're restricted to these numbers. There can't be any numbers in our domain that are not between 1 and 3, including 1 and 3. And that's because since we're plugging into g of x first, we need to make sure that all the values we're plugging in are legal for at least g of x. So this isn't our answer, but this is like a first step. We know that whatever our domain is, it's either this or it's something smaller than this, like that's inside of this. So it can't include any numbers that aren't already in this domain. So what is the other thing we have to consider? So the other thing we have to consider now is so now we're basically at this point. We have f of 3x. So once we plug in our g of x in for f of g of x, now we want to make sure that everything we're plugging into our f function is also allowed. So that means we would need to look at the values we get for g of x, and we want to disregard any values of g of x that don't work in the domain of f of x. So if we look at these three values, we notice that only this one right here, this 3, would actually be able to go into f of x. So that means that even though 2 is in the domain for g of x, 2 can't be in the domain of f of g of x, because once we plug in 2 into g of x and get 6, we can't then plug 6 into f of x because 6 is not in the domain of f of x. So what we have discovered, so let's write down what we found. So we found that we basically found that only x equals 1 works for this rule. And so basically what we did is we did this step, and then we took what we knew about this information and then filtered it through here, and we found out only x equals 1 will work. And so actually this ends up being our domain. Our domain is actually just a single point in this case. It's just x equals 1. So this is sort of just like looking through it and reasoning it, but often we want to be able to algebraically show that this domain works. So let's show algebraically that this is true. So we start off in the same way. So we start off by observing, so we always start off by observing that our inside function, our g of x, that these are the only values. That it has to be either these, there can be no values outside of here. So we start in the same way. But to sort of algebraically go about it, what we want to do is we want to say, okay, so we want to know basically for the domain of f of x, what values of 3x still give us legal values. So when we plug in 3 of x for x, like we do here, what are legal values that'll still work? So what we have to do is we just want to, sort of like just having an equal sign, we want to make sure we're doing the same algebraic operation to each part of our equation. So here we're just going to divide by 3. So 0 divided by 3 is just 0, 3 divided by 3 is 1, and 3 divided by 3 is 1. So now we have basically, I'll use orange here, we basically have two sort of rules. We found out that our domain has to be between 1 and 3, including 1 and 3, and also it has to be between 0 and 1, including 0 and 1. So basically when we have these two rules, what we want to do is be like, where we need to find basically the intersection of these two sets. And maybe a less mathematical way of saying that would be, what points in this first set are the same as the points in this set? And let's go ahead and just draw a picture to kind of help maybe make that clear. So let's just draw some number lines. Try to make them line up. Okay, so we know this first set here includes 1 and goes all the way to 3. And we know the second set starts at 0 and includes 0 and goes all the way to 1. So basically what we're doing with these two rules is saying, what numbers do these two rules have in common? And we can see from these drawings that the only place that these two lines overlap is at 1. So again, we've figured out that our domain is actually just x equals 1. And so when they're asking for an algebraic way to solve it, they're basically asking you to go through this step where you're taking your input function, in this case your g of x, sort of plugging it into your domain and of your f of x, and seeing what values of g of x will give you legal values to plug into your f of x. And it's not always just one point, right? You can get, sometimes it's just one point, sometimes you have an infinite number of points. So say, for example, that, let's just take this example, but let's say for some reason, this set was all the way to 2 instead of just 1. So now we have an overlap from between 1 and 2, and so our answer would be this would be our domain, all the numbers between 1 and 2. And obviously that's not true for this case, but it's just sort of like an aside. If for some reason these were the two sets we had gotten out of our two rules, then this would have been our domain. I hope this video has helped you understand how to find the domain of composite functions, and I hope to see you